Alright guys, we are here to talk about arithmetic series here. Now, we have been talking about arithmetic sequences, but a series is a little bit different, right? So here's some features of a sequence, just kind of going back to something that we had talked about. Sequences, they have commas between them, right? They could be a list of numbers here. Maybe this right here is not the best representation of that. Let me see here. I'm forgetting where I'm at. Give me a pattern, even just like right here, right? So there's a series of a sequence of numbers, and they just have commas between them. But when I'm looking at this here, a series is a little bit different, right? So a series can be that same list of numbers, okay? And I can even just make up a new set right here. Let's say that this is the pattern. -8, -5, -2, +1, and 4. But instead of putting commas between them, what about plus signs between them? That's what makes it a series. So an arithmetic series is a sequence, an arithmetic sequence in fact, with plus signs in between the terms. Right, so that's the difference between a sequence and a series. Sequence, commas. Series, plus signs. Now, that's what I'm going to do here. So I'm going to add all of these terms together here. And something that could happen is I could actually complete this process, right? -8 plus -5 plus -2 plus 1 plus 4. All that is -10. So my final answer here would just be -10. Okay? Now there is a formula to help us out with that, right? And with that formula, we're going to see a lot of the same terms. A sub n, a sub 1, in. That formula that we have become so accustomed to, this formula right here is the way to do this process a lot quicker. Okay? So this is how to find the sum of an arithmetic series. Okay, we're going to use that formula. All right. So when we're taking a look at this here, think about this. Anytime you have a pattern, you don't technically need the formula, right? 8 plus -5, -13, plus -2, -15, plus 1, -14, plus 4 is -10, right? But if I just use this formula, okay, S sub n, what that means, it's the sum of n terms. That's what that means. So A is the answer of n terms, or just this particular term that we're looking for, but the S represents the sum. So think about this. How many terms am I trying to find? 1, 2, 3, 4, 5. So the sum of 5 terms, notice that's what this one is, right? 5, it's just the amount of terms. This one right here is just the first term, right, in the series. So what did I say? That first term is just -8. The A sub n is the answer of the last term in this pattern. So in this case, the answer for the last term is +4. And we know that 2 is just going to stay there, right? So I could simplify all this, obviously parentheses first, so -4 plus 2, -4 divided by 2, that's -2. -2 times 5, it all comes up to be -10. So I could use that formula, right? You might say, hey, if I'm looking at and we'll get into what this word means here in just a second, a finite amount of terms. Okay? Something that can be counted and that you can easily count and see all of them. You just might add them together, right? But we'll take a look at some other ones, and we'll see what you might try for this. Okay? So continuing on here. All right, let's say I have this pattern here. And again, the directions are just find the sum. Find the sum of the series. And here's the pattern. The pattern goes a little like this. 3 plus 11 plus 19 plus ... plus 59. Now, if you're not sure what this ... means, that just means that there still are terms there, right? But instead of writing out every single term, they're just thinking about, well, just kind of giving you a rough guess, it ends at 59, right? So there are terms here. We don't necessarily have to find it. You might find them. Maybe that's something that you want to do. For example, if you say, okay, 3 to 11, 11 to 19, looks like it's adding 8. I could just add 8 to it each time, right? And then see if I can come up with 59. See how many terms I would then have in the pattern. That's a perfectly acceptable way to do it. Remember, it's arithmetic, so we know it has to add a number each time. Let's try using the formula, though, instead of just trying to write this out. So again, here's the formula. The sum of n terms is the same thing as n divided by, multiplied by the quantity of a sub 1 plus a sub n all over 2. Okay, let's see if we can figure this out here. We know we're taking the sum, but think about this. We're not sure how many terms are in this pattern. Okay, so let's skip n. We'll come back to that. Okay, what about this? The first term, right? That's just 3. So we know that's going to be 3 right there. We actually even know what the last term is, right? The last term here, in this case, is just 59, right? But here's the issue. We don't know which term 59 is, right? So you could do a couple things. You could keep this pattern going, right? 35 plus 8, that number plus 8, keep going until you get 59. Or another way of doing this is to take a look at this formula. Recall a sub n equals a sub 1 plus n minus 1 times d. We have all of this piece of information except for n. Again, we knew a sub n was 59. We knew the first term was 3. Again, we don't know what n is, but we do know that our common difference is 8. This is going to tell us what term or what position the 59 is in, right? So 59 is the same thing as 3 plus 8n minus 8. Again, just distributing that. 59 is the same thing as 8n minus 5. Again, just combining some like terms there. I could add 5 to both sides, and it looks like 59 is in the 8th position. Right? So that means 1, 2, 3, 4, 5, 6, 7, 8. 59 would be in the 8th position. Right? So I could find my sum of my 8th term there. Alright? So, let's see if we can simplify this out. 33 and 59 make 62. 62 divided by 2 is 31. 31 times 8. 31 times 8. 248. So the sum of the first 8 terms is 248. Alright? That's the way to do it. You could, again, list out all the terms and see what happens from there. Alright? Sometimes you might have to find the last term in the pattern, right? So let's think about this here. Let's say, you know what? What if I have a situation, and I'm not going to try to make the problem exceptionally hard here, but let's say that I have this pattern right here, and I want to know a couple different things. If the first term is 1, oops, I want to make this a series. The next one is 3. Next one is 5. The next one is 7. Remember, there's more terms in there. I want to find the sum of the first 20 terms. Right? I want to find the sum of the first 20 terms right here. Well, think about this. I have my formula S sub n equals the quantity of n times a sub 1 plus a sub n all over 2. What do I know here? Is there any kind of pieces of information that I know? Well, I know n, right? N is just 20. I actually also know my first term, right? My first term is just going to be 1 in this case. So I'm going to make that a 1 here. Now here's what I don't know, right? I don't know what the actual 20th term is, right? So this might be a case where I come over here and use my a sub n equals a sub 1 plus n minus 1 times my common difference of a d, right? So these two formulas, they really work well together, right? If I don't have all the pieces of my summation formula, I can use my explicit formula that I was using really heavy in these past couple days and go from there. All right. So again, my answer for the nth term, my answer for the 20th position, I don't know what that is yet. My answer for the first, we already established that was 1. I know that there's 20 terms in this pattern, and it has a common difference of 2, right? It increases by 2 each time. Alright, so it looks like we can just do a little plugging and chugging here. 1 plus 19 times 2. We'd have to multiply first. 19 times 2 is 38. 38 plus 1 is 39. So my answer for that 20th position was just 39. Now I actually have it. So it looks like 40 divided by 2, 20. 20 times 20 looks like the sum of the first 20 terms here. Something's not right here. So 1 plus that is 40. 40 divided by 2 is 20. 20 times 20 is 400. Give me 1 second. I'm going to pause this and come right back.